Good afternoon, everybody. I hope you had a nice break. Welcome to the afternoon session. And we are in the breakout room of transformative agri-food systems. So you're welcome for this session.
Recording in progress.
We are going to have our presenters, and the presenters will be allowed to do 12 minutes in total. That is 10 minutes of presentation and 2 minutes for discussion, where somebody who has a question may raise it, and then the presenter will be given opportunity to respond. Now, our first speaker for the afternoon is Njogu. Njogu, are you there? Is Njogu logged in? Hello?
We can't hear the...
Hello? Is Njogu logged in already?
Yes, Daktari, can you take us back to the break room?
Oh, the IT. Just a minute. Just hold on. We are sorting out a few technical issues here. Very soon you will be let into the breakout room.
And Lillian will be presenting now on my behalf, and then I present later after her.
Oh, Lillian. Oh, okay. So is Lillian ready?
Yes, I'm ready, Doc.
Okay, Lillian is going to be our first presenter this afternoon. That is Lillian Jeptanui. And her presentation will be on evaluation of finger millet, leucine, Corocana genotypes for blast disease resistance and grain yield. So Lillian, we shall give you 10 minutes and keep to time, and then you will have 2 minutes of rebuttals. So you can take the floor.
Thank you, Daktari. Good afternoon, everyone. My name is Lillian Jeptanui, and the title of my paper is Evaluation of Finger Millet Genotypes for Blast Disease Resistance and Grain Yield. I co-authored the paper with Dr. Miriam, Dr. Andrew Dilong, and Professor Kimukto. This is the outline of my presentation. I'll do a brief introduction,
recording stopped,
and a conclusion. So finger millet is a major cereal in semi-arid tropics.
Sorry, we lost her. Lillian, are you there? Hello? We lost Lillian. Hello? Can you join the room? Lillian, can you hear me? Lillian, can you hear me? Please, if you can hear me, please join the room. Please, the other members who are interested, could you join the room?
You are not in the room.
I'm in the room. I think I joined. Pardon? I'm in the room. Lillian, can you hear me? Lillian is there, but I'm not sure. We're in this crop science plant protection room. Hello? Nancy Jog, if you can hear me, the presenters for this session, could you please join our thematic area, which is the crop science, crop protection? We are under transformative agri-food thematic area. Hello?
Hello.
Is Lillian there?
Prof. Kimu, joining through the breakout rooms.
Yes, thank you, Dr. Ukwiri.
Yes.
I was trying to call the two presenters.
Okay.
I'm not able to get them, but maybe you can call in the next presenter, because it looks like they started and they went off.
Okay. Thank you, Professor Kimochi.
She has just joined.
You're back?
Oh yeah, she's back.
Yes, I was taken to another room, the animal production room.
Ah, okay. So you're back now. So kindly, if you're ready, load your presentation. Put it in the presentation mode, please.
Okay, can you now see my presentation?
Yes, you can see your slides, but put it in the presentation mode, please.
So from my side, I can see the full mode.
Okay, then
So
just, okay, continue. Just start.
Can I proceed?
All right.
So I was saying finger millet is a very nutritious cereal and a very important crop worldwide. It's estimated to be produced at
Recording in progress.
Asia and Africa. India is the leading producer. Unfortunately, Kenya is the least producer in East Africa. Finger millet is facing challenges mainly on yield, and the productivity is still very low, about 800 kilos per hectare. That translates to just 300 kilos in an acre. And amongst the challenges that is causing the yield losses is a disease called blast disease, which is a fungal disease. Again, in Kenya, we lack stable high yield in cultivars that would reduce and increase the yields. This disease is very prevalent in all finger millet growing areas, and it can cause up to 18% yield losses. The objective of this study was therefore to evaluate for resistance to blast disease and grain yield among 64 selected finger millet genotypes.
Lillian, your slides are not moving. Are you moving them?
Moving from my side, they are moving.
Oh, okay. Just continue then.
Okay, so the 64 genotypes were evaluated for blast resistance and grain yield in 2 sites. Worked in Calro Alupe, Ikrisat in Busia, and also in Baringo, ATC Koibatek. My research was done in 2 seasons that for the 2 environments, that is March, July, and September, December, the year 2020. The genotypes were planted in an 8x8 square lattice design and with 3 replications. The genotypes that I evaluated were sourced from Ikrisat, Calzo, and Egerton University. They included 8 Ikrisat advanced breeding lines and another 8 commercial varieties. Amongst the genotypes were 4 checks. P224, which is high yielding and resistant to the disease. Nakuru FM1 is also high yielding and moderately resistant. U15, which is also high yielding and moderately resistant, and KNE 741, which served as my check, and for susceptibility because it's early maturing and very susceptible. For yield data, I collected several variables from germination up to harvesting, the 1,000 seeds weight, and calculated the grain yield from 2 middle rows per plot. Then I translated it to tons per hectare. For the disease, I was using a scale of 1 to 9 to measure the severity. Unfortunately, you cannot see the image of my scale, which was running from 1 to 9. 1 was representing very highly resistant, and the foliage was clean without any infection. And 9 is very highly susceptible, and the disease is covering most of the leaf. And then for the neck blast, I was also using a scale of 1 to 5, and class 1 represented a resistant genotype with no lesions. Class 5, a very susceptible genotype, and most of the neck was covered with the disease. Data analysis. For grain yield, data was subjected to ANOVA using SAS release 15. Then I did an AMI for G and E interaction in additive, main, multiplicative interaction, the AMI. For the disease, I transformed the data and calculated the area under disease progress curve using a model by Wilson et al. 1975. I measured the monthly average rainfall for the 2 sites for the 2 seasons. And for season 1 in Koibatek, the average rainfall was, the total rainfall for the 4 months was 530 millimeters. For Alupe, it was 985. And also in the second season, Alupe had the most rainfall, averaging at a total of 985 again, 785. And Koibatek season 2 was the least rainfall with only 320 millimeters. Then I did, on average, the yield across the sites range from 0.7 tons to 2.6 tons per hectare. And in Alupe, the site was the leading in terms of yield, followed by Alupe season 2. Koibatek was the least for the 2 seasons. Some of the highest yielding phenotypes across the 4 environments included Ekama, Kal, Emuru, amongst others. And the least performing in yield across the sites and also seasons were Nakuru FM1, genotype called ending extern and lower. So I have a table that is supposed to show us the varieties that performed best across the 4 sites or the 4 environments. For Alupe 1, it was U15, KNE 1124, KNE 796, and Oale 1. For Koibatek, I had Koibatek season 1, IE 4115, Oale 1, KNE 796, and KNE 1124. Alupe, we had season 2, we had different varieties performing best. Chemical and KNE 624. And lastly, for Koibatek season 2, the best performing varieties were U15 by snapping, KNE 624, and Ambo. So I did an AMI analysis of variance for grain yield genotypes under the four environmental conditions. In this case, I was considering Alupe season 1, season 2, and Koibatek season 1 and season 2 as different environments.
Lillian,
Yes.
just a minute. Could you, for us to see your slides, because nobody is seeing those slides from this side, could you stop sharing and start sharing again? Just stop sharing and then start again, so that we can see your slides, because you're not seeing anything. Kindly. Yes, now we can see your slides. Continue. Continue. Hello?
Hello.
Yeah, you can continue now. We can now see your slides. Just continue.
This slide is part of the results for yield, and it is the AMI ANOVA for yield in tons in the four environments. Like I was explaining before, I consider the two seasons in each side as different environments. And the main effect of G and E accounted for 7.8 and 69% respectively. And for G and E interaction, it accounted for only 13% for the total variation in terms of grain yield. The principal component 1 accounted for 93%, while principal component 2 accounted for 7%.
Hello? Lillian, are you there? Continue.
So there was more disease severity in Koibatek compared to Alupe for both the seasons. Koibatek had the highest disease at an average of the mean of 4.5, Alupe just 3.5. In both cases, the genotypes were affected mostly in the first season than in the second season.
And you have only 2 minutes, so please.
The most resistant genotypes identified, as you can see, I hope you can see my slide.
Yes, we are seeing your slide.
15 by snapping KNE 624, Sirogal and accession 14. The most resistant were moderate yielders, and some like Bulu E and Egerton were poor. So that's the genotype performance on blast by environment. From the graphs, you can see there was more disease during Koibatek season 1 as compared to the rest, and the least of the disease was in Alupe season 1. And this clustered some of the most resistant and most susceptible genotypes per site. This is in Koibatek. We have the most susceptible as KNE 439 and KNE 741, while the most resistant were Egerton and IE 4497. In the same case for Alupe, where we had the most susceptible as KNE 439 and the most resistant KNE 1034. So in conclusion, from the study, the four environments, that is Alupe 1 and 2, Koibatek 1 and 2 are significantly different. The genotypes perform differently across the environments in terms of grain yield and disease reactions. The most high-yielding genotypes were moderately resistant to blast, while the most resistant genotypes were moderate yielders. There was more disease pressure in Koibatek as compared to Alupe, and the genotypes yielded better in Alupe as compared to Koibatek. And these are the recommendations for the study.
Now I'll stop you. I think you have gone past the time, and then I'll open the floor for questions.
On the chat so far, nobody has managed to pose a question.
Okay. Is there anybody from the audience with a question to Lillian?
Maybe I can ask.
Okay, fine.
Okay, Lillian.
Yes.
Now, you find that finger millet is usually affected with other diseases like smut and rust. Now,
Yes.
how did you manage to take care of their symptoms so that you can take only the severity for blast? Because you didn't control these other diseases.
Thank you, Dr. for that question. The finger millet symptoms and effects are very unique. And besides, the other two diseases you mentioned are not very prevalent in finger millet, but blast shows the symptoms so well. So I was able to distinguish from the other diseases because of the severity in the leaves and the neck. Yes.
Okay, let me just ask you a small one. Did you find any genotypes that were combining blast and yield, and how stable were they now that you did AMI analysis?
Yes, I found several varieties, several genotypes that were stable in the four environments, and they were also resistant to the disease.
Okay.
That was U15 by snapping, KNE 1034, and KNE 1124.
Okay, thank you, Lillian, for your presentation. We now move to, I hope Nancy is ready now. Nancy, can you hear me?
Yes, I'm ready, Dr. Let me share my.
Okay, share your slides and then take it on. So Nancy is going to present on fall armyworm infestation and grain loss in advanced sorghum genotypes in arid and semi-arid areas in Kenya. So,
Okay, can you see my slide? Can everyone see my slide?
Not yet.
Not yet.
Not yet. Share your slides, please.
Just a minute.
Share, so that we can see. So Nancy is a PhD student in the Department of Crops, Horticulture, and Soil.
Can you see my slide, Dr.
Can you open it? We can see your screen, but you have not yet opened the slide. Just open the file, the PowerPoint file.
Make sure you open it before you share so that you just go on your desktop and get it.
Yeah.
And no, is it okay?
Not yet, not yet. Have you opened it?
Yes, sir.
Can you stop and share again? Stop sharing your screen and share again. We can see your screen, but the file is not open. Or should we share from our side?
Is that?
Oh,
Is it
now,
okay
now we can see it. Okay, just go on
Okay,
now.
fine.
Go on.
Okay, thank you. Okay, thank you, Dr. Good afternoon, everyone.
Good
So
afternoon.
my name is Nancy Jogu, and I'm here to present to you a research topic entitled for armyworm infestation and grain yield loss on advanced sorghum genotypes and the field conditions in arid and semi-arid areas in Kenya. This is a field evaluation of sorghum genotypes on fall armyworm, and those are my co-authors, and that is the outline of my presentation. And sorghum, we still appreciate sorghum as the drought-tolerant crop and food security crop, especially for arid and semi-arid areas. And just like I had mentioned before in another presentation, FAO still is a problem. And now I'm concentrating in the field with the field evaluation to see whether we can get resistant sorghum genotypes, especially because most of the research which is being carried out currently are focusing on maize as far as fall armyworm is concerned. And on my left side, I have a sorghum plant which has been severely damaged by fall armyworm. And on my right side, I have a larvae damaging the panicles. So the problem that we have as of now is still lack of sufficient understanding of the type of the pesticide, that is, there are limited trials. And particularly, there is lack of resistant sorghum genotypes. And this time they focus on evaluating these sorghum genotypes to see whether you can get host plant resistance. And also, we assess the mechanism of resistance in the field by the selected sorghum genotypes. So from this study, we are expecting to get grain yield loss in sorghum, which will provide potential threat and impacts of FAO, which can guide policy intervention. As of now, there are no reported cases of losses caused by sorghum, fall armyworm on sorghum, although a lot of field study has been done on maize. So I'm trying to generate knowledge in terms of interaction of FAO with the new environment because it is a new pest. So my study site of the evaluation was done in 2 sites. One is in Kiboko and the other one was in Koibatek. This is where these are arid and semi-arid lands where there is high infestation of this pest because of the high temperature. And I worked on 49 advanced sorghum genotypes, 35 genotypes from the Gene Bank, that is the Genetic Resources Research Institute, and 9 from Wiki Research, and 1 commercial variety Kalimutama 1, and 4 local varieties, that is Wagita, Busia 30, 3, and Siaya 6. The experimental design was an alpha lattice, that is 7 by 7, that is 49. The experiment was done in 2 seasons in both sites, that is Kimboko and Koimbatek. And the plots were 3 rows, 2 meters in length, and the spacing was 75 by 25 centimeters. And in order to access the damage which is being caused by the fall armyworm, I had a protected and an unprotected experiment, side by side, protected by 10 meters of maize, so as not to interfere with the drift, spray drift on the protected experiment. So the data correction, I looked at the larval count from 5 plants. I also counted the egg mass. I also looked at the FAO incidence and the larval damage rating. And I was doing this one during 2 stages, that is at the seedling stage, that is at the 3-leaf stage, and at the whole stage, that is the 6-leaf stage. And I did the damage rating evaluation at a scale of 1 to 9, according to Weissman. And CMIT has also modified the damage rating. And the agronomic data that I took was plant height, 1,000 seed weight, tillers, grain yield, and maturity. So this is the damage rating scale that I used, which has been done by Weissman and has been modified by CMIT. And it ranges from 1 to 9. So when I came to the field, I discovered that apart from the fall armyworm, stalk borer is also another problem, which is now compounding the problem of fall armyworm. And instead of getting losses being caused by fall armyworm, it is being caused by a complex of the two. So I also did some scoring on the stem, on the stalk borer tunneling, stem tunneling, which was very high both in Coimbatec and in Kiboko. And in Coimbatec we had Busiora fusca as a stem borer, and in Kiboko we had the Chiropatellas. So I evaluated the damage by counting the number of nodes on 5 plants and the number of nodes with exit holes. And I looked at the percentage damage being caused by the stalk borer. That was number of nodes with exit holes over the total number of the nodes. The data analysis, I analyzed my data using GenStat release 14, and I separated the means using LSB. And I did simple correlation coefficient. And I did data transformation for the insect and the egg counts. And I did the homogeneity of error variance in order to be able to combine the data across the two sites using the bat rate test. So that is the formula used for the yield loss estimation. I compared the two protected and the unprotected trials. I took the difference and divided by the protected trial to see how much we are losing for not protecting the sorghum. And that is the statistical model for the varieties across the sites and across the seasons in the two sites. So the results showed, the ANOVA result showed significant genotypic variation for the traits among the test genotypes, and there was significant interaction between the genotypes and the sites, genotype and the seasons, genotype and season, site and season, and the loss, the green yield loss I observed from the two sites are quite interesting, because in Coimbatec, during season 1, I was able to get 63.24%, which was very high season 1, compared to season 2, where I got 24.23. Average for Coimbatec was 43.74. In Kiboko, season 1 was a very short season, which ran just from November to March, and the damage, the loss was only 32.8%, compared to the second season, which was now longer from May to October, that is 43.73%. So the yield losses, the green yield resulting from these losses, you can see like for Coimbatec, we only got 0.8 tons per hectare, which was very low. Second season was a very cool season, which was rainy, and we managed to get 2.44 tons per hectare. In Kiboko, the overall the yield was 1.44 tons per hectare, and now the overall across Kiboko and Coimbatec was 1.55 tons. So the overall green yield loss being caused by the fowl and the stalk borer complex is 39.18.
You have 1 minute, so try to finish up.
Yes. Okay, thank you, sir. So this is the main table, which is comparing the seasons and the sites. And as you can see, season 1, the first infestation or the first damage rating is normally lower than the second one. That is during seedling stage compared to the whole stage, and it happens for the larval count and also for the incidence. And these are the genotypes that performed well, and as you can see, genotype 00124 had very low damage rating and reasonable yield. So this is yield against the damage rating. As you can see, these are compact sorghum hens which had this infestation. And those are the stem tunneling, and these are the neck exertion. The genotype with the low neck extraction, like what we have on the left side, has got higher infestation compared to the one which is well exerted. So because of time, I think I can go to my conclusion. And I realized that the mechanisms for the host plant resistance in this standard would be antibiosis, panicocompactness, and teloring response, tolerance, and also escape through fast flowering and maturity. And these traits can be used in breeding for fall armyworm, stalk borer, management, and these ones were the genotypes which were resistant. Sorghum genotypes which can be used for further breeding, and they can be used in IPM. And I also recommended that it's good
So,
we do
Nancy,
some body
Nancy,
yeah.
I'll stop you.
Yeah.
Thank you. I'll stop you. And welcome. I've given you an extra 1 minute. And welcome questions from the floor. Kindly.
No questions from the chat so far?
Nancy, I'll ask you 2 questions. One, you had fall armyworm infestation and stalk borer, right? That's what you say.
Yes, sir. Yes, sir.
How did you then relate the, let's say, the infestation levels of fallworm or the damage levels of fallworm to yield when you had both diseases? How did you remove the effect? Because there could be some confounding effects.
Thank you, Dr. Ali, for that question. It is the question that I still have and which I have tried to put in my recommendation, that because the 2 insects are damaging the forage and they're also damaging the grain, the panicles. At this stage, I can't be able to separate in the field. But in the lab, maybe someone can do a modeling experiment and get the damage being caused by each one of them. But for now, the damage which is happening in the field is by the complex. That is both the fowl and the stalk borer.
Okay. And the second one, you say the mechanism you found is antibiosis. How? Because from your field research, how are you able to determine the mechanism?
The antibiosis, one of the resistant mechanisms is antibiosis, because there are some 2 genotypes which, when I did the damage evaluation, the damage rating was very, very low across the season, and also the larvae, the size of the larvae was very tiny. They, instead of the way they normally grow in size progressively, I just had tiny small larvae, which were looking like the second instar, meaning that the genotypes were hindering the development of the insect, which could be antibiotic mode of mechanism of resistance. So it is just suggested.
Okay, very well, very well. Thank you for your presentation. There's another question from the floor.
Okay, Nancy.
Yes?
Just something small. Now, when you look at the fall armyworm, you have maize and sorghum. If the 2 crops grow together, which one is the fall armyworm likely to prefer?
Nancy, are you there? Hello?
Nancy, you got me?
We lost her, so thanks. Let's move to the next presenter. Maybe she has a technical hitch, but you can always respond on the chat, because the chat is open. You can post your answers there. Now, we move to our next presenter, and that is Ntakanio. Do we have you in the room? NP. Ntakanio, NP, are you there? Hello? Hello? I cannot see from the list of participants. So if Ntakane is not there, let me move to the next presenter, Jeb Kosgei. Jeb Kosgei, S, I don't know what S stands for. Are you there, Stella? Stella? Stella Jeb Kosgei. Stella? Stella, can you hear me? Is she logged in really?
She's not logged in.
Stella is not logged in. Musafiri?
Collins is there.
Collins is there. Collins? Musafiri? Can you hear me? Collins Musafiri? Hello? Collins?
These people are just logged in.
It seems people are logged in, but they are not in the room. I move to the next presenter. Do you have Dr. Lelmen in?
Yes, I'm in.
Yes, doctor. Now that the other presenters before you are not in the room, I'll give you the opportunity to make the next presentation if you are ready. Are you ready?
Yeah, I'm ready.
Okay. Dr. Lelmen is going to give us a presentation on performance of different storage systems on physiological quality of wire potato in Elgeyo Marakwet County in Kenya. So could you mount your presentation? Mount your presentation.
Okay, let me get the presentation to
and share your screen. Yeah, put it in the presentation mode, please. You have 10 minutes for presentation and two minutes for questions. So once you're ready, just start. Just start.
Okay, good afternoon.
Good afternoon. Good afternoon.
I'm Dr. Lelmen, and I'm presenting on performance of different storage systems on physicochemical quality of ware potato in Elgeyo Marakwet County, Kenya. Potato is one of the Kenya's strategic food reserve crops, among the leading enterprise supporting food and nutrition security, employment creation, and income generation crop. It can bridge the gap during shortages of the staple maize crop. It is mainly farmed by smallholder farmers, and it's an essential source of dietary fiber, energy, protein, vitamins, and micronutrients. In Elgeyo Marakwet, it's a resilient crop. It can secure vulnerable livelihoods under the effects of climate change and changing markets environment. Most farmers sell their fresh potato produce with limited value addition. In some cases, we have processing to crisps and chips in both household and cottage industry levels. So the problem that is being addressed is that the constant availability of good quality tubers at predictable pricing regimes is hampered by post-harvest losses as a result of inadequate on-farm storage facilities and inappropriate choice of potato varieties. This normally there's surplus during bumper harvest, which reduces market prices, and scarcity on the market when the potatoes are still in the farm, causing the prices to drastically increase. So still on the problem, 3 storage systems are traditionally used in Elgeyo Marakwet. We have the diffused light stores, we have the ambient charcoal stores, and the cluster up as shown in the figures. However, the system's suitability on the quality of raw and processed potato tubers has not been fully elucidated. For the justification, the nutritional and processing quality of potato and its storage is influenced by physical processes including weight loss, sprouting, greening, shrinkage, and rotting, and biochemical processes including transpiration and metabolic breakdown, which are directly related to tuber variety, storage temperatures, and storage relative humidity. Therefore, there is need for farmers to use food storage that can minimize losses and extend tuber shelf life as a considerable component of ensuring improved market access to future food and nutritional security. So the objective of the study was to compare the effects of storage in DLS, charcoal, and hard stores on the physical and biochemical quality of 4 potato varieties as shown in the figure. Changi, Egerton, Martins, and Destiny. The varieties are suitable for all potato growing areas in Elgeyo Marakwet. They have a high demand, either for market or for processing of crisps and chips. Establishing appropriate storage systems for these popular varieties will enhance farmers' livelihoods, ensuring availability of adequate produce for processors and also for food. So the potatoes were sourced from the farmers' field and also Agrico East Africa. The potatoes were packaged in 4.5 kgs per bag. The bags are shown, and the storage samples was brought in triplicate samples for 8 weeks with storage management. The store temperature and relative humidity were recorded daily. So looking at the effect of storage on physical parameters, all tubers were weighed, all tubers in a bag were weighed weekly for 8 weeks. For weight and other parameters including sprouting, greening, shrinkage, and rotting, the parameters expressed as a percentage of the total number of tubers in a bag. So on the effect of storage on biochemical properties, there was analysis of raw tubers and also processed into either chips for Shangi and Magis varieties or crisps for Destiny and Egerton varieties. The processed samples and the raw are all, we had composite samples for each. These were taken for nutrient content analysis in the TMP laboratory Nairobi. For the effect of storage on biochemical properties, the methods for starch, reducing sugar, and protein content are as shown. For the temperature and relative variation, the mean range of temperatures were as shown from ranging from 9.6 degrees Celsius to 19.3 degrees Celsius, and the temperature and the relative humidity range from 65 to 93%. Ranges higher, temperature ranges were higher than the requirement for potato storage temperatures. while the relative humidity ranges were lower than what is required. Let's go. Parameters. We look at the mean. We look at the tuber weight loss. In all stores, mean percent weight loss differed among all tuber varieties and increased with increased storage time. Weight loss in each store was less than 11% with 8 of the storage. And Shangil in DLS began losing weight by week 2, and by week 8, the loss was significantly higher than Shangil in charcoal or heart. Weight loss resulting from tuber evaporation limits post-harvest longevity of tubers and therefore an indication of deterioration.
Hello, Doc. Are you there?
Yeah, I'm there. It has moved. The state was stuck.
Okay.
Okay, so the next physical parameter is sprouting and greening. And sprouting indicates breakdown of dormancy, which reduces fertility, induces shrinkage, and accelerates weight loss with increased respiration and transpiration from sprout growth. There was no greening seen in Destiny, in charcoal.
You have 1 minute, so kindly try to wind up.
Okay.
Just continue.
For physical parameters, protein among all varieties was less than 2%, with no significant differences. By week 8, ELS and Shangi had a significantly higher tuber shrinkage than that in heart or charcoal. Marquis in charcoal and had significantly higher shrinkage than that in heart or charcoal. Moisture loss played a significant role in tuber shrinkage and was related to the less than 90% relative humidity and greater than 10%, 10 degrees Celsius temperature in the DLS. Starch content among all varieties and stores, the mean starch content decreased its storage time. By week 8, raw Marquis DLS is the highest starch. And in all stores, starch in raw Shangi was significantly higher than in Destiny. In all stores, the processed tuber varieties stored for 8 weeks at the highest starch content. Reducing sugar content in all stores increased significantly with storage time, and by week 8, all raw Shangi had significantly high sugar, while Marquis was significantly the lowest. By week 8, the sugar levels in all varieties in all stores were higher than those reported by Ambo 2015, but within the acceptable level of 100 milligrams.
Dr. Lalman, sorry, your time is up. I've given you 1 extra minute. So I'll stop you there and then invite the audience to ask questions. For the audience, you are encouraged to use the chat. You can type your questions there, or you could raise your hand and ask directly. So, Dr. Mafura.
So far, nothing on the chat.
Okay.
I'm not seeing it.
Okay, Doc, I'll ask you maybe one. You said you got your varieties from the farmers, some of your material that you used for the experiment.
Yes.
So how did you ensure that that material had a varietal purity?
Maybe I didn't get the question clearly.
You got your materials from the farmers,
Yes.
and sometimes farmers have mixed materials. So how did you ensure the uniformity of your test material?
We ensured that we contacted the farmers who had grown the varieties we were interested in, and we went to ensure that the harvest, we get the harvest immediately. They get the harvest from the farm. We get the potatoes immediately harvested.
Okay. Very well.
Also, we also sorted the material. So you remember we said something like we have a diameter of greater than 60 millimeters. So for all the material that we use, we ensure the variety is correct, and we sorted them so that we start with uniform starting material for storage for our experiments.
Okay. Now, what key result would you say you got from your work that would be of interest to your audience?
From our results, we can say that the store's charcoal, GLS, and hard stores gave desired physical and biochemical characteristics of low tuber weight loss, graining, shrinkage, and rotting, and low levels of reducing sugars that are desirable for processing. And that these tuber varieties can still be used to process chips and or crisps directly after storage or after 8 weeks.
Okay, thank you for your presentation. Thank you very much. Now, I would like to revisit some of our presenters that were not in the room. I'm not sure if they're back. We had Ntakanyo. I think Ntakanyo had not logged in, but we had Msafiri. Is Msafiri,
Yes,
are you in?
Yes.
You're in. Okay, then prepare to present your slides to us. Now, Msafiri is going to give a presentation on minimum tillage and productivity of smallholder sorghum cropping systems of Kenya. So, just load your presentation and put it in the presentation mode. You can continue typing your questions on the chat, and our presenters can continue responding in those chats. So make use of the chat. So Msafiri, kindly, when you're ready, just load and put in the presentation mode. Okay, can you put it in the presentation mode, please? Okay. You can continue. You can continue now.
Yes.
Just go on.
Welcome. Yes. Welcome to my presentation titled Minimum Tillage and Productivity of Smallholder Sorghum Cropping Systems of Kenya. I'm Collins Msafiri, and the paper is co-authored by Kiboi, Masharia, Ngetich, Kosgei, Mulianga, Okot, and Professor Felix Ngetich. And this is the outline of the presentation, where I will run from the introduction, methodology, discussions and results, conclusion and policy recommendations, and acknowledgement. And in the introduction is that climate change and soil fertility decline are the major drawbacks to ensuring sustainable agricultural productivity in sub-Saharan Africa. Conservation agriculture is a set of practices which are aimed to enhance agricultural productivity and at the same time reducing resource wastage and also protecting the environment. And the conservation agriculture is anchored under three principles, where one is reduced soil disturbance, soil cover, and also crop diversification. And minimum tillage is one of the principles of the reduced soil disturbance. And minimum tillage has the potential of enhancing soil carbon buildup, thus promoting soil health for improved crop productivity. And studies show that there are inconsistent implications of minimum tillage adoption among smallholder farmers, where experimental studies point out that minimum tillage utilization has a significant impact on improving crop productivity.
There's a problem with the connectivity. The IT. Yes, I think so. Sorry, Msafiri, for that technical hitch. You can pick it from where you left.
Recording in progress.
Yeah, just continue.
And the main challenges facing sorghum production in Western Kenya include the birds menace, also low productivity, especially due to erratic and unreliable rainfall, and also includes yield. And now, in cooperation or joint assessment of the adoption of conservation practices like the minimum tillage in the climate smart crop is important, so that it can be used to assess whether if you combine drought-tolerant crops and conservation agriculture principles like minimum tillage can enhance productivity. And also, adoption of minimum tillage and drought-tolerant crop among smallholder farmers could be essential in enhancing Kenyans' Vision 2030 achievement and also the sustainable development goals like zero hunger. And the objective of this study was now to identify or assess the determinants of minimum tillage adoption, assess the determinants of sorghum productivity for minimum tillage and conventional tillage smallholder farmers, and also assess the impact of minimum tillage adoption on sorghum productivity. And the methodology, the study was conducted in Western Kenya, in Siaya County, and the two sub-counties were selected, Alego Usoga and Igenya sub-counties, and their characteristics, whereby the differences and similarities in the study area, the two sub-counties were highlighted: population density, agroecological zones, rainfall, the smallholder land holding size, the soil, and also the temperature. And in this study, a cross-sectional survey design was performed, and a sample size of 300 smallholder farming households were sampled, whereby the sample size was reached out based on the Cochrane formula, and the actual sampling procedure which was employed was a multi-stage sampling procedure, whereby the sampling unit was the smallholder households. And the actual data collection was collected using a face-to-face interview schedule, whereby the key variables collected were sorghum yields, the minimum tillage adoption, and this is the decision whereby whether a farmer adopted minimum tillage or practiced the conventional tillage, and explanatory variables including households and farm characteristics, soil fertility perceptions, institutional variables, and also the area of residence of the smallholder farmer, and in this case is whether the farmer resided in Alego Usonga or Ugenya sub-county. And the data was collected using an open data kit mobile app by well-trained enumerators. And for the statistical analysis, descriptive statistics were performed to summarize the data, and a stochastic dominance analysis was employed to evaluate whether there is an overlap between the conventional tillage farmers and the minimum tillage farmers. A propensity score matching was also used as a robust check, and an endogenous switching regression model was employed. Results and discussion, and we summarize the descriptive characteristics, and we find that there are differences in the descriptive characteristics of the smallholder farmers between the minimum tillage adopters and the conventional tillage farmers. And for instance, we find that the remittance receipt was higher among the conventional tillage farmers as opposed to minimum tillage farmers. Therefore, the table highlights the differences between the minimum tillage farmers and conventional tillage farming households. And then you have the stochastic dominance analysis results. And from the stochastic dominance analysis, it can be seen that there is an overlap between minimum tillage and the conventional tillage farming, and therefore the common support region is fulfilled. And then you have now the determinants of minimum tillage adoption, and this is now the first objective, whereby you have, like, when you run the endogenous switching regression, it has 3 outcomes, and this is the first regime, whereby it produces the determinants of the choice, and in this choice it is the adoption of minimum tillage. And we find that there are different predictors of minimum tillage adoption, like occupation, whereby we find that smallholder farming households whose main career was farming were more likely to adopt minimum tillage compared to the farmers who engaged in off-farm activities. Also, you find like a predictor variable like the area, the acreage, was also a positive determinant of minimum tillage adoption. You find like smallholder farming households who received the weather forecast information. This was a negative predictor of minimum tillage adoption. And then now you have the determinants of sorghum productivity, and this is the second stage of the endogenous switching regression, whereby it segregates the productivity into 2, the productivity of conventional tillage farming households and the productivity of minimum tillage farming households. And in this equation, if you look at the raw value, it implies that the raw value was significant, and that the utilization of the endogenous switching regression model was plausible. And also when you look at the log likelihood test of independent equations, and in this case, these are the 3 independent equations: the equation for adoption of minimum tillage, equation for productivity of conventional tillage farming households, and equation for the productivity of minimum tillage adoption. And this is significant, implying that there is interdependence between the 3 equations, and therefore, if this data was analyzed separately, it would not be plausible. And we find that there are both significant determinants of conventional tillage farming productivity and minimum tillage productivity. And then you have the average impact of minimum tillage adoption of productivity. This one is used in the propensity score matching, whereby 4 algorithms were used, and there was no significant difference between the conventional and minimum tillage farming households. However, now when we look at the minimum tillage adoption impact on sorghum yields, we find that we have the decision stage, whereby you have the actual adoption and the actual non-adoption, and if either choose to move to the other direction. And we find that if minimum tillage adopters choose not to adopt, their productivity will be 11% higher, and if conventional tillage farming households who did not adopt choose to adopt minimum tillage, they could enhance productivity by 15.1.
You have 1 minute, Collins. 1 minute. Just wind up.
If non-adopters decide to adopt minimum tillage, they could improve productivity by 58%, and therefore minimum tillage adoption should be promoted among smallholder sorghum farmers for improved agricultural productivity. Thank you.
All right. I think you have kept time. Thank you very much. Now I open the floor for anybody who has questions for Collins. You can raise your hand on the Zoom, or you can write a question on your chat. Or if you have a question, just shoot it. Anybody with a burning question for Collins?
Thank you, Collins. Now, when you talk about minimum tillage, which type of minimum tillage did you specifically employ in this particular case? Because there are several types.
For this study, I employed smallholder farmers who are implementing reduced tillage.
Which one specifically? Did you use herbicides, just uprooting, or which one specifically?
For this case, they are the smallholder farmers who were not implementing the conventional plowing of the farm, but they were having small holes for planting, and then during the weeding, they uprooted the weeds instead of the farming, the plowing.
I think what you did was, when you are going to, you are doing research, and you are doing minimum tillage, you know there are several types. We want to know, when you employed this is the outcome. This is the outcome. When you reduce the weeding, which one did you employ specifically?
Collins, are you there?
Yes.
Could you respond? Or you would prefer to respond later or write on the chat?
Yes, I respond on the chat.
Okay, fine. Thank you for your presentation. I see Stella in the room. Stella, are you back?
Yes, I'm back.
All right, now it is your turn to make your presentation. We skipped you because when we were looking for you, we couldn't get sound from your side. Now, Stella is going to give us a presentation on the efficacy of selected biopesticides on pod borer management and yield performance of pigeon pea in arid and semi-arid areas of Kenya. Stella, you can take the floor.
Okay, thank you, Doc. The title of my presentation, you've already said, and it is co-authored by Professor Paul Kimuta, Dr. Cheboy, and Kangarao Rao. That's my presentation outline. At introduction, pigeon pea is the third most important legume in the world after bean, and it has several uses, and some of them are it is a source of protein, whereby you find that we find 20 to 30% protein in food and in the human diet when it is consumed. Other uses, among other uses, it is currently produced in over 5 million hectares of land, and most of the land is most of the area that is producing is India, making it the largest producer in the world. But when we come to Eastern and Central Africa, Kenya is third after Tanzania and Malawi. So pigeon pea is being affected by several pests, including pod borer, which causes low productivity, especially in dry land areas of Kenya. So insecticides, in the past, they have been used to try to control this pest, and you find that it has several disadvantages or several setbacks, including that these insecticides, they are environmentally unstable, and hence you find that they are also expensive to the farmer. They also cause damages to or contamination to groundwater, hence causing pollution. So as such, you find that there is need to shift focus on more reliable and environmentally friendly methods and that is the use of biopesticides. So this research gave birth to evaluating several biopesticides to find out which one can effectively control these pests as well as increase the yields and improve its productivity. As to constraints of production in pigeon, we find that caterpillars, the pod borer caterpillars, they destroy the buds and flowers. I think I've mentioned that, and the control and the methods of control that farmers have been trying to use so as to reduce it. To materials and methods, this research was done in Colbate and Capcayo location, both in Baringo and Elgeyo Marakwet counties respectively. We had 3 treatments, that is 3 biopesticides, namely nimbedicine, Piagro, and BT, that is bacterial Bacillus thuringiensis, as our major treatment. And then we had 1 positive control, that was Dudukine, and negative control that involved no spray. We used 2 varieties, that is Egerton M1 and EUMDP4. Both varieties, they are moderately tolerant to this pod borer attack. These were made in split plot design with main plots being the pigeon pea variety, while the subplots were these pesticide treatments, and we replicate them 3 times in 100 by 40 centimeter plots. We had 5 sprays at vegetative stage, 50% flowering, 25%, 50% podding, and 5%
Someone, hello? Someone on the background, please.
Musafiri. Musafiri, mute.
Sorry for that. So in that table 1, we teach the details of the pesticides and insecticide treatments that were used in this experiment. Now, into data collection, the population of pod borers and nymphs and eggs were made 24 hours before spray and 2 days after spray, respectively. We collected data on pod damage, the severity on leaves and flowers, percent incidence, percent pest reduction, yield, and yield component. And then we subjected this data to ANOVA and separated the means using LSD at P is less or equal to 0.05. To results, you can clearly see that before treatment, the number of eggs, nymphs, and adults across all the treatments, they seem to be uniformly distributed. That was because the chemical has not been sprayed. But after spraying, all the biopesticide treatments significantly reduced pest populations as compared to untreated control, which seem to remain the same in terms of the number of these adults, nymphs, and the eggs. From these tables, we can clearly see that nimbedicine, this one as the first treatment, it gave us the best effects on pod borer control because it significantly reduced the pest population as compared to this untreated control. These results, we can compare these results with the studies that have been done in the past by several researchers like Ahmad et al. 2018 and Kumar and Bustan et al. 2018 that reported that the neem or azadirachtin gave them the best effects in controlling the pests. In this table, it shows the percent pod damage, the severity, percent incidence, up to the yield. And here we can also see that medicine gave us the best results as compared to the positive control Beetroot, all the way from pod damage severity up to the yield, whereby we see the medicine giving us the second best yield after Beetroot, which was our positive control. That one I've explained. That is yield that is presented in graphically, showing that the leading treatments, Beetroot, was giving us the highest yield, and then followed by medicine and Piagro and BT. These results also was in agreement by the same.
You should be winding up, Stella. You have only 1 minute left.
Yes, I'm winding up the time. And also the Bushan et al., they reported the way they reported that azathioprine giving them the best effects in controlling the pest, they also translated to giving them the best yields. In correlation that was carried out, he could clearly see here the severity of the leaves and flowers and seeds per pod incidence, they were positively correlated to the pods per plants, which clearly translated to the yield, meaning that when the pods and flowers are affected by this pest, it is going to significantly affect the yield. So in conclusion, we can conclude that medicine and Piagro can be recommended for effective control of the pod borer in pigeon bees, especially in dryland areas of Kenya. The use of medicine and Piagro, it is not only environmentally friendly and suitable, but also their use can greatly increase yield and improve productivity in pigeon bees. My acknowledgement goes to Kaisa Pigeon Bee Project at Egerton University for funding this project. My deepest gratitude and sincere appreciation also goes to my supervisors for their guidance and encouragement throughout my research period, and also the staff and at Kapkayo and ATC Coimbatore. Thank you.
Thank you, Stella, for a good presentation. Now I'll open the floor for questions.
We have some questions from the chat. The first one is, explain in depth on data collection on severity of leaves, linking with the ANOVA analysis done. Explain in depth on data collection on severity on leaves, linking with the ANOVA analysis done. Secondly, data on pod damage.
Yes.
Data on pod damage was categorical or not? Categorical or not? If the data was categorical, how did you carry out the correlation analysis? If the data was categorical, how did you carry out the correlation analysis? Thank you, Chair.
Can you respond?
If I can respond to the first one, on how I carried out my data on severity of the leaves, I used a scale of 1 to 5, 1 being the least affected leaves and 5 being the most affected leaves. And then I converted the scale, if it was 1 or 5, I converted it to percentage and then analyzed it.
Okay.
You are supposed to link this to ANOVA analysis you did.
Okay.
Do you have an idea?
Let me respond.
Or is it the question is not very clear?
It's clear.
you also have the opportunity to do the rebuttal on the chart. Yes.
Yeah, I have one small one.
Okay. Go on.
From the results she's showing there is that a BT is performing terribly. What do you ascribe this to? Yet we know BT is one of the foremost very effective insect controls, especially which order of insects were you looking at?
I was looking at Helicobacter and Meteor.
Yeah, which order are they in?
Maybe Chair, I can help I'm one of the co-authors.
Okay. Just.
Yes, I can respond to the question of the BT from Professor Mulu. I think when you see the poor performance of BT, most likely is environmental. In these dryland areas, the activity of some of these organisms become highly affected by high temperatures and the heat. So you would see that it is not doing as well as we may be expecting. So I think environment is a big problem, or a big contributor to the low performance of the BT as compared to the common insecticides or the others that fairly bit better than the BT. So I think that could be
in that case, Chair, then I think the student can improve this work by discussing it in context. Huh?
Yes.
Yeah,
because
I agree.
Put it, yeah.
I agree. Thank you, Chair.
So I hope you followed the conversation, Stella.
Yes, I did.
You also have the opportunity to do consultations. Pardon?
So just endorse for me.
Pardon? Someone speaking? Oh, probably it is background noise.
Okay. Another question here. How did you quantify the amount of biopesticides used? How did you quantify the amount of biopesticides used?
Okay. From my presentation, there's a table I presented, and that's how I measured my treatments according to the doses that have been written at the cover of the bottles of the biopesticide that are used. As for example, in medicine, it was indicated 0.5 liters per hectare. So I narrowed that down to what was required by the plots I used, that is 100 by 30 centimeters, which gave me about 4 millimeters of the treatment plot.
Did you have a standard protocol that you followed?
Yes.
Okay, I think you can continue the conversation. For me, my recommendation, I saw you used 2 varieties, right?
Yes, I used 2 varieties.
But then your results do not show the effect of the pesticide vis-a-vis the variety. So I think that needs to come out so that we see if there are some interactions, because it's a factorial experiment. Okay, thank you for your presentation. I'll move to the next presenter. I see Ruiro, you're logged in. Ruiro, you're logged in. Are you there?
Yes, I'm here.
Is Grace?
Yes, Grace Ruiro.
Grace, okay. Grace, you can load your presentation, and then you do the talk. Okay, Grace is going to give us a presentation on evaluation of rice, that is Rhiza sativa, genotypes for yield and resistance to blast disease in Kenya. So you can take the floor. Grace, put it in the put your presentation in the presentation mode and just start.
Okay. Thank you. So my name is Chris Riro, and thank you.
It's not yet on the, you're not on the presentation mode. Can you click on the presentation mode?
Can you see my screen now?
Yes, you can see it now. Go on.
I'd already moved from the first page, the introduction page, but thank you for this opportunity. My name is Chris Riro, and I'll be presenting on evaluation of selected rice genotypes for yield resistance to blast disease in Kenya. And my co-author, I'm the author and the co-authors are Professor Kimurta, Dr. Miriam Tarimbo, and Dr. John Kimani. So I'll start by saying just rice is approximately food or a staple food for 3.5 billion people in the world. And in Kenya, it's the third most important cereal after maize and wheat. Rice has become a popular meal in Kenya due to consumer preference, due to urbanization, and also its ability to cook easily, and hence the demand is exceeding what we produce. So
Hello?
hello.
We lost you. Just continue.
Okay, so rice production, it contributes to about 20% of the world's total calorie consumption. Then rice has a total production of about 7 billion tons worldwide. In Africa, having a production of about 6 million tons, and in East Africa, we have 1.3 metric tons, with Tanzania being the largest producer within the East African region. So India leads in production with 44 million hectares being plowed, and in second place whereby we have China. The rice production in Kenya is about 45 to 80,000 metric tons, against the demand of 300,000 tons that we are having as a country. So rice is faced by various challenges of production. We have low soil fertility, mainly due to waterlogging. We have pests and diseases, especially the Kolea birds when it comes to the Kirinyaga County, especially the Moya region. Then we have diseases like blast, which can lead to total loss. Then we have cold weather, we have soil salinity, planting of old commercial varieties, or having those old commercial varieties being plowed for a long time, like basmati, which is NIBAM 11, and lack of proper adoption of the upland rice that have been produced and released. So the objective of this paper was that to determine the yield performance and adaptability of selected rice genotypes for yield resistance to blast disease in major rice growing areas in Kenya. So onto my materials and methods. And sorry, before materials and methods, I would say that one of the things is that the statement of the problem is that when it comes to production and the consumption, we are at about 75% deficient of production when it comes to the blast disease. You get that it leads up to total loss of the rice crop, and also we have the disease, which leads to total loss, and also we have the old commercial varieties being still in stock in the market, which has brought about lower yield production instead of the adoption of the new varieties that we have in the market release. So materials and method, we had 2 sites, that is in Kirinyaga County and in Kisumu County. In the area of Kisumu County, we were at a Hero irrigation scheme, and Kirinyaga was at Karo Ikrimwea. That's where we did those were the research sites, and the genotypes that were evaluated were 26 different genotypes, ranging from commercial breeding lines, and they are on our screens that we can see. Those are the varieties that were produced, we used during the research. So we had a field experiment that was laid out in was laid out in a partially balanced lattice design that is 5 by 5, repeated 3 times, with each plot size being 1.4 meters by 1 meter. Seeds were planted in rows with a spacing to plant of 0.2 meters to 0.5 meters between the plots, and 1 meter spacing between each rep. 5 spreader rows of susceptible varieties of Basmati G70 were planted around the experiment field. If it's visible in our screens, we can see that's how that the field layout looks like. And the scoring of the infection of the disease was done after the susceptible spreader rows was infected, approximately 5% of the disease severity. So, going to data collected, the various data that was collected, we had agronomic data, which was days to tillering, days to booting, days to first flowering, tiller number, plant height at physiological maturity, the grain weight, the 1,000 grain weight, the biomass, and rice plus disease scoring using the 0 to 9 scale, which is on our screens, where 0 is no disease, and by the time it's at 9, it's more than 75% infected. So onto data collection and analysis. We had agronomic and yields that were obtained from 5 randomly selected plants, and in the middle of the rows and of the plots, the selected plants were used for every data collection procedure, so that we would ensure that there was the data was reliable. Then later there was a test for the assumption of the analysis of variance. The quantitative data was subjected to Leven's test of homogeneity, followed by anomaly tests using the Shapiro wheel. So we also subjected data to analysis of variance using statistical software SAS, version 9.2 procedural, ProcGLM, and this was the single site analysis. The first model and second model was used for the 2 sites for the agronomic parameters of the data that was collected earlier. And data analysis also, a continuation, adaptability was determined by computing the correlation between genotype and the environment. The genotypes that were high yielding were termed as adaptive to the environment, that they were growing in the same environmental conditions since both were planted at the same time, and also the practices were the same, the farm practices were the same, the management, and so the genotypes that were high yielding were termed as most adaptive. And also the genotypes that had low rise,
Grace, you have 2 minutes, so try to move quickly.
Okay.
Yes.
Thank you.
Just continue.
Onto the results. We have the analysis of variance. Before we go to that, I would want to share maybe the means of the yield, as is on our screens, on the ranking when you compare the Moya and the Ahero. And one of the things is that in Moya station, we will find that Arise Stage Gold would do better, Komboka and Ofanten. When you come to Ahero, that was the same, with having a production of 5.11, 4.5, and 4.0 and 3.0 tons per hectare. And also the number of tills per hill were, the way they were rated is that Basmati, BW 196, Saro 5, and Mir 2 were leading with 26, 28, 25, and 22 respectively. The lowest producing genotype in both areas was BW 196 with 1.6 tons per hectare. In the Ahero irrigation scheme, we find that the same Komboka was and Ofanten Arise State Gold were leading with 9.37, 9.00, 8.87 tons per hectare. That means that Ahero really did better than when it comes compared to Moya. Onto the correlation, we'll find that correlation for analysis of yield components, growth parameters, show that 1,000 grain weight and the straw weight were positively correlated with the yield. Generally, there was a negative correlation between the leaf blast disease and the yield. So, allow me to go to the conclusion and recommendation. Because we're short of time, sorry. So the genotypes of Anten, Komboka and the rice stage both performed really well across the sites and across all the seasons. Cold stress in Moya reduced the yield up to 25% in the April to June season that was not suitable for the crop. And then the effect of leaf blast affected the total yield, though indirectly, but it affected the whole process of crop growth and interfering the process of photosynthesis. It mainly occurred just before flowering. That's when the leaf blast was pronounced, and it's when it had started manifesting in the crops. Then also conclusion and recommendation is that genotype of Antian is the most resistant to leaf blast across the two sites and the different seasons, and also it was among the highest yielding. The correlation analysis of the study revealed that the number of tillers per plant and panicle length, the total plot weight other than grain weight, and the days to maturity were the most important yield components. This study recommends that genotypes of Antian, Komboka, and the rice bolt to be evaluated on rice growing areas for yield and other traits. The released varieties such as Komboka will be promoted for production, and also that there will be availability of certified seeds in the system.
Grace, I'll stop you. Sorry, Grace, I'll stop you. You are really pushing beyond time. So thank you for your presentation. I open the floor for questions.
I have not seen any question on the chat so far. Maybe those members who are just attending, they can voice their questions through.
From the audience?
Chair, may I ask a question?
Yes,
Sorry,
yes. Go ahead.
I was trying to type, but I have not finished.
Yes, Prof, just go ahead. Just ask. Prof, can you hear me? Professor Wagara. Hello? I think we are having a problem with the IT.
Recording in progress.
Sorry. Hello?
Hello.
Yes, we had a small hitch with our IT. Professor Agara, you had a question. Could you please repeat?
Oh, yeah, thank you.
Yes.
I want to find out if there were any local addresses that were evaluated for rice blast, and if so, how did they perform?
Grace, could you respond?
I didn't get the question, sorry.
Oh, Prof, could you kindly repeat?
The question is,
yes,
in the evaluation for blast, were there any local or addresses of rice that were tested, evaluated, and if so, how did they perform?
Okay, they were there because we evaluated 26, and their performance, especially that of Komboka, was the production was good, but also they were very susceptible to, moderately susceptible to the blast.
okay. Prof. Agara, are you through?
Yeah, that's okay.
All right. Any other question from the audience? Okay. There being no question, Thank you, Grace, for your presentation. Oh, I had one. You used correlation analysis to look at which trait was important. Hello, Grace.
Yes, I'm here.
You talked about using correlation analysis to, I didn't get it clearly, to identify which trait was key in.
No, I used correlation analysis to check which traits were negatively correlated between one another, and mainly I was checking the leaf blast and the yield.
Okay, fine. Thanks for your presentation. The next presenter I see logged in here is Quizera. Quizera, are you there?
Yes, please, I'm there.
Enoch Quizera. So could you load your presentation? Then you give your presentation. Now, Quizera is going to give us a presentation. Just load your, as I introduce your topic, kindly just load your presentation and put it in the presentation mode, ready for presentation. Now, Quizera is going to present on the effect of Biochar on growth, yield, and quality of beetroot. Could you load your presentation? Open it and put it in the presentation mode.
Can you see my slide, please?
No, I can see your screen, but we can't see your slide.
Open the document.
Yes, open the document.
Can you see it now?
Yes, it has shown up, but now put it in the presentation mode. All right, you can start.
Thank you. My review is on the effect of Biochar on growth, yield, and the quality of beetroot, and it was quoted by Professor Opio and Professor Nancy. This is the crop I'm working on. As the introduction, beetroot, it has the scientific name of Beta vulgaris, belonging to the family of Chinopodiaceae, and the species has been originated from the southern Europe, known as the wheat beetroot. It is among the vegetable crop which mainly grown for roots, and also the leaves can be consumed as the spinach. And it also contains minerals, vitamins, and antioxidants. As the importance, red beetroot shows the vital importance to represent main significant market of vegetable crops, and also it can create the employment among the small-scale farmers, and also for those who are belonging in its value chain. Its production, worldwide beetroot is being grown on 7 million hectares with 240 million tons seasonally as its production. In Africa, the yield of beetroot is being shifted from 1.21 to 7.3 million tons in 70 to 2020. In Kenya, farmers are getting about 25 to 30 tons, with Nakuru, Kiambu, and Tarakaniti being the leading producer. The factors affecting beetroot growth, among them there is fertilization. The continuous use of synthetic fertilizers has been contributed to low yield of the crop. This is because when the farmers keep on using the chemical fertilizers, they lead to leaching and also leaching of nutrient, and also the which can reduce the yield. The soil amendment contributes to the chemical and physical properties of the soil. Among them, there are soil microorganisms and also soil aeration, which can facilitate in the absorption of the nutrient by the crop. The soil organic amendment can also sustain the nutrient storage and also the availability in the soil, which contributes to increasing the crop yield. The production of biochar. Biochar is a type of charcoal made by pyrolyzing biomass in the absence of oxygen. For this biochar to have a good quality, 500 degrees Celsius must be used in the manufacturing process. As the effect, biochar can contribute in the rising of pH of the soil and also provide a defense against the soil-borne disease. As materials and method, the review has been done by reviewing the different articles about different methods used to amend soil. Moreover, the articles were focusing on the new methods used to alleviate low or to fight against low soil fertility globally and also in the African countries. The potential of biochar on beetroot growth. Application of biochar has proven the ability to improve chemical and physical properties of the soil, as I explained earlier. And it also stimulates the growth of fine roots, which can change the carbon cycle, fertilizer effectiveness, and also water nutrient health.
Hello? Hello? Quizera, are you there? We lost him. Quizera, can you hear me? Quizera? We lost him. So, we have lost Quizera, it appears.
Did it come back?
He has gone off. So, maybe as we shall give him opportunity to present if he manages to come back. Maybe out of those who are logged in, I see CTNA. Is CTNA logged in? CTNA. I can't see CTNA either, but just a while ago she had logged in. Okay then. Do we have Duncan? Duncan Otuan.
Yeah, is there?
Who? CTNA?
Duncan.
Duncan, can you hear me?
It's screen.
Oh, CTNA is back. CTNA, are you there? Can you hear me?
Unmute yourself, please. Philip.
Philip, can you unmute? Can you hear me now? Hello?
He's unmuting.
Oh, okay. Let's have Duncan go first. Duncan, are you ready? It appears we have a hitch somewhere. Philip or Duncan, if you hear me, if you can hear me out, unmute.
Yeah.
Who is that I'm speaking to?
Yeah.
Philip. There's a problem with network. Hello, is that Philip? Are you having challenges with your network?
Hello.
Hello, I can hear you
You're
now.
getting me?
Is that Philip?
This is Philip.
Philip.
Yes.
Yes, Philip, I give you the opportunity to be the next presenter.
But I'm not even seeing you.
Oh, but you can hear me.
Yes.
Yes. So you just load your presentation.
I'm not seeing. Hello?
Hello? You can't see your query somewhere.
Yes.
You see your query somewhere. Hello?
I can't even see you, but I can hear you.
Now can you load your...
You don't need to see us. Just put on your presentation.
Yes, just put on the presentation, please. Just load it.
Can you share?
Yes.
Can you see my presentation?
No. I'm seeing the
not
ceiling.
short.
I'm seeing the ceiling from your camera.
So you share, screen share.
I don't know what is the challenge.
Are you screen sharing?
You share your screen. You have been granted that that permission, the rights to share.
Just a minute.
Yeah, I can see you on the video.
Boss, you can see me.
On the video, yes.
So,
But we don't need to see you. We want to see your presentation.
Yeah, we need your presentation, not your image.
Are you seeing the presentation?
No. I'm seeing you.
But
Go to screen share first.
Share your
Click
screen.
to screen share.
Share your screen. Share your screen.
Go at the bottom there and click on share screen.
There's a green button there which says share screen.
Yes.
Have you clicked on it?
Just a minute. Okay. This one?
You can see it yourself.
Yeah.
Yeah, it's starting, yes. Okay. Now share, yeah, it is here. Can you put it in the presentation mode now?
Okay.
Yes, you can start now. Go ahead.
Okay, thank you. Yeah, I was carrying out a study on the occurrence of aflatoxin in groundnuts, a case study of 4 counties in Kenya. The others, Sichene, myself, Professor Kimusho, Professor Wagara, and Professor Bonyo. Introduction. Now, aflatoxins are toxic secondary metabolites that are highly toxic and produced by Aspergillus species, mainly by Aspergillus flavus, followed by Aspergillus parasiticus, and then Aspergillus nomis reali and Aspergillus tamari. So they have been grouped into 4, the naturally occurring ones. We have aflatoxin B1, aflatoxin B2, aflatoxin G1, and aflatoxin G2. Now these are the fungi responsible for the production of this aflatoxin. We have the front part and then the reverse part. So the route of exposure to aflatoxins, how does this aflatoxin get into the body? You can inhale, you can ingest this food consumption, or sometimes through the skin. So once in the body, they cause the effects like they cause cancer, there is hypertoxicity, there is suppressed immunity, there is the teratogenic effect, mutagenic effect, there is stunting growth in children, and sometimes it causes death. Now, because of those effects,
well, aflatoxins are linked to liver cancers.
Yes.
Prof. Mulwa, kindly.
Oh, okay.
We can.
So,
yeah. Okay.
You can hear me?
Yes. Continue.
Yeah. Okay. So, because of these effects, we have countries that have set maximum limit levels that are allowable in their countries. We have European Union, 4 parts per billion. Kenya, we have 10 parts per billion, and then USA, we have 20 parts per billion. This is for the total aflatoxin. So, because of these limits, the negative impact, there is a direct loss. There is a direct market loss. It means countries that produce these groundnuts cannot export their produce. There is interventions, that is to control either post-harvest or pre-harvest, then it will cost money. Then there is cost of illness because of aflatoxin. And then there is also cost of regulations and for research programs. Because now a lot of research focuses on the aflatoxin. So materials and method, groundnut samples were collected from Baringo, Elgeyo Marakwet County, Bungoma, and Siaya counties. Aflatoxin analysis was performed using a ELISA kit. Now, 100 grams of the samples were ground using a commercial blender, and then it was weighed. 20 grams of the samples were extracted using 70% methanol, and then it was allowed to settle down, and then the suspension was filtered using Wattsman #1 filter paper. Then, of course, total aflatoxin ELISA kit was used, and aflatoxin analysis was performed according to the specifications of the manufacturer. That is the flow chart. We have the samples here. These are the ones having the pods. So you remove the pods. and then you grind using blender, and then you weigh, and then of course you extract using 70% methanol, and then you carry out aflatoxin analysis using ELISA kit, and then from there you do the OD readings from ELISA reader, and then now from there you get the results and you analyze. Now, what are the results? Okay, so from the study, the groundnuts from Baringo and Elgeyo Marakwet County, EMC stands for Elgeyo Marakwet County. The range was 2.05 to 2.36 parts per billion, mean being 2.2. For the Elgeyo Marakwet County, we have 0.0 to 2.56. And then we have for Bungoma, it was 0.36 to 36.88 parts per billion. And then for Siaya, it was 0.74 to 113.37. If you look at these samples, if you look at samples for Baringo, they meet the limit set by the European Union for 4 parts per billion. Because all the samples at 100%, the levels were below the 4 parts per billion. For Bungoma, 90% will meet that one, and then of course for Siaya, 60% will meet. Between 4.1 to 10 parts per billion, it was 0 for Baringo and 0 for Elgeyo Marakwet County. Then it was, of course, for Bungoma it was 0, and then for Siaya. But now beyond 10, we have 4 from Siaya County and then 1 from Bungoma County. So in discussion, from the study region, we realized that groundnuts are widely consumed in Kenya. And then groundnut samples from the 4 counties, they are contaminated with aflatoxin. However, aflatoxin levels were significantly higher in Western region, that is Bungoma region, Bungoma and Siaya, and then in Kerio Valley region, that is Elgeyo Marakwet and Baringo County. So groundnuts from Western region, that is the 2 counties, Bungoma and Siaya, can have negative impacts on human and livestock health. This high level in Western region can be attributed to climate. We have high humidity, we also have high temperature, and then there can be presence of highly toxigenic aspergillus strain in the soil. Of course, and then, but from as much as in Western, as much as in the Kerio Valley region, they are actually low. They are safe for human consumption. However, long-term exposure can also be harmful. So, groundnuts from Western region need to be monitored in order to protect consumers from the effects of aflatoxin. Actually, the samples were analyzed immediately after harvesting, meaning there was no post-harvest contamination. So aflatoxin detection on-site is needed. And then, of course, the majority of households in Kenya, they are exposed to either acute or chronic aflatoxins.
Philip, you have only 1 minute left.
Yes.
So, okay, conclude. Fine, it's okay.
In conclusion, there is a variation, there is income variation in concentration of aflatoxin within the county and from different counties. And therefore, that the fact that aflatoxin testing was done right after harvesting, then it may indicate that in some regions, there is a widespread nature of the toxigenic strains. The toxigenic strains are those responsible for causing aflatoxin. Because usually these Aspergillus species, we have the atoxigenic ones. They are in the soil, but they don't produce aflatoxin. And then we have the toxigenic strains. Acknowledgements, we have ADB, African Development Bank, then we have USAID, and then we have National Research Fund. They funded the project. Thank you for listening.
Thank you, Philip, for your presentation. I open the floor now for any comments.
Maybe we start from the chat?
Yes.
Okay. From the chat, one, you have said aflatoxins are secondary metabolites. Which are some of the examples? You just have to maybe note some and then you'll be able to give us the feedback. Then secondly,
okay. Can I respond?
No, let me go through and then you'll be able to respond, yeah?
Okay.
Then secondly, what were the explanations for high level of aflatoxins and the proposed solution to protect consumers from contamination? What were the explanations for high level of aflatoxin and the proposed solution to protect consumers from contamination? Lastly, on the chart, when extracting using methanol, both primary and secondary metabolites are extracted. How did you differentiate which were aflatoxins and which ones are not?
Okay, so let me start from the first one. The first question, you say that the examples of this are secondary aflatoxin. I said at the beginning, we have aflatoxin B1, we have aflatoxin B2, we have G1 and G2. Those are naturally occurring aflatoxin. But then we have, of course, we have M1 and M2. That one will result from metabolism now in mammals. If you feed your cow on contaminated feed, and then in milk you will get either M1 or M2. The question number 2 was on, you are saying that the cause of variation in aflatoxin levels. So number 1, naturally there are a number of factors that contribute. If you look at the pre-harvest factors, it may be actually the way, if you like crop protection programs, if the farmer has continuously maybe growing groundnuts or maize in the same land for a long time, it means the pathogens, that is Aspergillus species in the soil, will continue multiply because they get enough nutrients. Now, during harvesting, if you harvest these groundnuts during during the dry season, if there is a drought, and then the drought, you will expose the groundnuts to aflatoxin because one, the groundnut plant cannot produce phytoalexins, which assist in resistance to this aflatoxin. And then sometimes when the farmer is harvesting, these pods may crack. And if they crack, it forms an entry point for these Aspergillus species. Another point, now it depends on the region. In some regions, the soil have toxigenic.
Philip, could you move to the next maybe question? Could you respond to the next question?
Yeah, so the next question was on, you see, if you extract the aflatoxin from the groundnuts, the grounded groundnuts, you get secondary metabolites, which is aflatoxin. Now, the question is, how do you know these are aflatoxin or other metabolites? I used aflatoxin ELISA kit. So it is able to detect only aflatoxin. If you use total a kit for total, it means it will detect only aflatoxin B1, B2, G1, and G2. If you use, for example, for B1 only, it will detect only B1. So that is the work of the kit to detect the aflatoxin levels.
Very well.
Yeah.
Okay, thank you, Philip. I just wanted to inquire, when you collected your samples, did you collect them from the farmer stores or you collected them from the field in the markets?
I collected the samples during harvesting from the farmer's field. Not at the store, but during harvesting. So I took the samples and then I ensured that it reached the lab immediately, and then I stored in the fridge to avoid multiplication of the Aspergillus species.
Okay, thank you. Just a last one. With your data, I saw when you are presenting your data in terms of the results, I saw Baringo had a relatively higher amount of aflatoxins than that of Bungoma.
Sorry, come up again.
In your results, I saw Baringo County had relatively high amounts of aflatoxin levels than Bungoma. Can you respond to that? Why is it?
Not really. I said from the results, the CIA is leading. Yeah.
No, just show it. Just go where the results are.
Yeah.
No, next. No. Up.
Yes, that one.
Yeah, that one.
Yeah, that one.
You see, in Baringo, we have 0.0, the range. The list was 2.05 and the S was 2.06. And Elgeyo Marakwet County, the list was actually not detectable. Okay?
I'm talking about Baringo and Bungoma. Baringo and Bungoma, please.
And then Bungoma, you see Bungoma, we have the list sample recording 0.36 and the highest was 36.88. And then Siaya, we have the list being 0.474 and the highest was 1.137.
It's okay. I've seen it start
So
6.
From this, you can see that we have the highest is Siaya, and then we have Bungoma, and then Baringo, and then the last.
Thank you. Maybe another question from the audience, if there is.
I think those questions are enough. He has pushed beyond his time for questions. So, looking at the list of presenters, there are some presenters I've realized who are not in the house, and there was a presenter whom I think we lost in the process of presentation, and that presenter has not yet come back into the room. So, so far, I think I have one more presenter, unless if the presenters who are not in have got somebody who may be standing in for them. But I can't see any of the authors in the room. So, Duncan Otuan, are you there? Duncan?
Yes, Chair.
You ready?
Yes, Chair. I can hear you.
All right. Duncan, you need to share your screen.
Philip, stop sharing your screen.
Philip, can you stop sharing your screen? Philip? All right.
Yes, I'm doing that.
Okay, stop sharing and then mute yourself so that we can hear from Duncan. Now, Duncan, as you prepare, I'll just introduce your topic. Duncan's topic for presentation today is the role of working capital management on financial performance of small-scale coffee processors in Ambo County, Kenya. So Duncan, if you are ready, please kindly load your presentation. Share your screen and unmute yourself. Duncan?
Yes, Chair. I'm loading it. Yes,
You load and then you share your screen.
Oh.
You have technical issues?
Yes, a bit. Sorry, Chair, because I'm trying to load.
They're not there.
While the form.
They're not in there.
I had.
Can you share your screen? Share your screen. At the bottom there, click on the button, share screen, so that we can see your window. Hello? Can we share from our end if you have issues?
Yes, please, I'll appreciate. I'm having issues with this one.
Okay, let us share from our end then. But, okay. It's coming up.
Okay.
So you'll be prompting us to move your screen when you want to move to the next slide. Okay? You can begin the screen is already up there. You can begin your presentation.
Okay, thank you, Chair. My name is Duncan Oswon, and I wish to present on the... Sorry, Chair, there is another one. It's not this one. I had two papers to present, and I had informed I'm supposed to present on the one on the role of working capital management.
Okay. It is just being loaded by our IT personnel. Just hold your horses.
All right, thank you.
So, were you supposed to present two today?
To present two. I'm just wondering if time will allow, but I had two papers to present.
Okay. The IT. Just hold on a little as we load.
Okay.
Okay, can you see it now?
Yes, I can see it.
Okay, now you can just continue.
Okay, thank you very much. I'll introduce myself as Duncan Otuon, and I'll present on the role of working capital management on financial performance of small-scale coffee processors in Ambo County. And the co-authors are Dr. Gatimbu, Mr. Mustafiri, and Professor Felix Metich. Just on the introduction, next slide, please. That is the paper, the presentation outline. Next. So we begin by appreciating the importance of manufacturing sector in development of global economies, and particularly in Kenya, we appreciate that this sector is driven by agriculture and service sectors, and it contributes a significant percentage to our GDP and foreign exchange earnings. However, in the growth of this sector has been curtailed by agro-processing industry, coffee subsector being one of them. We also appreciate that utilization of assets efficiently can improve performance of these industries. It also helps the farm have enough cash flow to be able to pay its day-to-day expenses such as creditors and other day-to-day operating activities. Then working capital management is important in determining the financial performance of an organization. Let's proceed. So in the past few years, the Kenyan government has put in place some measures in trying to improve or rather revamp the coffee subsector. And some of these measures include there was operationalization of the 3 billion Kenya shillings coffee fund. There also exchange regulations which have been reviewed. There also a review of the waiver to 4%, that is fees from the coffee marketing. All these measures have been there to try to increase the return to farmers. However, coffee prices still are on the decline, and the wet mills, rather coffee processors, still continue to record very low profit margins, and therefore the researchers and in this particular sector have tried to understand what could be the problem, and therefore we are trying to look at the working capital management. What could be the issue with the management of working capital in these wet mills? Hence, we settle on Ambo County and trying to look at the effect of working capital management on their financial performance. Next slide. Next, please. Methodology. The study was conducted in Ambo County. The population size is over 600,000. The mean annual temperature given there around 20.2 degrees Celsius. The rainfall altitude, and the main soil in this region is the humic native soil with moderate to high inherent soil fertility. Next. We used convenient sampling design, the sample from 56 coffee processors. Then out of these 56, 9 of them were excluded because they didn't meet the required data that we needed. And we used quantitative correlational research design and analyzed 5-year panel data, that is from 2014 to 2018. Next. The analysis We used SATA software, and the analysis was conducted by help of multivariate regression analysis. I just continue. And moving to the results. The results, we separated the means, and we classified the coffee wet mills on two categories. One, based on their APP, where we had unconstrained and constrained average payment period. That is what I refer to as APP. And also we used current ratio, that is desirable or undesirable. And these are the measures we use to measure or to operationalize the independent variable, that is working capital management. So we measured working capital management using average payment period and current ratio. And the means, as you can see, we show that the constrained APP farms had higher APP, higher current ratio, and higher growth rate, where we are having the reds, and the age and the size. The unconstrained APP farms had a higher age and size in terms of the difference, where you are seeing the greens. The same applied to the classification under current ratio of desirable and undesirable. You can see where we are having the green and the red marked. Next. We also conducted some tests before running the multivariate regression analysis, and from the correlation and the multilinearity, you can see that the variation inflation factor here, it ranges between 1.1 and 1.04, with a mean of around 1.05, and therefore, since the VIF was less than 10 and the rho values, as you can see here, less than 0.5, our independent variables were therefore fit for multivariate regression. Next. And here we are now doing the multivariate regression. We have two dependent variables, the return on assets and the return to farmers. The APP, or average payment period, you can see it has a negative and significant effect on return on assets, similar to current ratio, capital expenditure denoted by CE, and also age also has negative effect, and they are significant. So the return to farmers, the average payment period and current ratio, they both have positive influence on return to farmers, similar to debt ratio, capital expenditure, and the farm size, while the age has negative influence. Actually, the age here, as you can see, is a confirmation that the prices of coffee have been declining over time. So as these farms grow old and old,
Duncan, you have only 1 minute to go. So wind up. Okay.
Thank you. That's the last slide.
Okay.
We therefore conclude that the average payment period and the current ratio are necessary in improving the coffee processors' return to farmers, and recommend that these farms, the coffee processors, need to increase their average payment period and current ratio to be able to increase their returns to farmers. Next slide. Thank you very much. And these are the institutions I appreciate: the University of Ambo County Government, Egerton University, and Jaramogi Oginga Odinga University of Science and Technology. Thank you.
Okay, thank you, Duncan. We have noted that your presentations fit very well into tomorrow's thematic areas on agribusiness management and agricultural economics. So we have decided that the next presentation, you can do it tomorrow. You'll be given a slot tomorrow in the afternoon under that thematic area. So, but now that you have done this presentation, we open up the floor for any feedback that may be there.
So far, there is nothing on the chat. maybe from the audience.
So we open the discussion. If anybody has any burning issue to raise, could you please just raise it? Okay. There being no questions from the floor, I would like to thank all the presenters and the participants for making this session very lively. It has been very informative.
One didn't finish.
And sorry?
Quizera, is he there? He didn't finish. So.
No. I checked on the chat. He was not there. I've checked. I've not seen him. He's not in the room. He's not in the room. So, Quizera is not in the room, so I would end this session there. Just a few announcements. You will log out of the room, but do not log out of the conference. The IT officer will, at the end of the session, put up a poll which the participants will be expected to respond to. So you may log out of the room, but go back to the main presentation kindly. Thank you for participating.